We've discussed utility AI and learned a little bit about the theory of how it functions. Let's dive a little bit deeper into Athena AI specifically. To start with, I'm going to discuss a diagram pulled straight from the Athena AI documentation because it does a far better job of explaining the data flow for Athena AI than I can personally. I'm not going to be doing a deep dive into how to create your characters and thus variables in this series. That'll be informed by your architecture and design choices. The first part of this that we need to understand is the BP character. This is just some entity that we want to be controlled by the Athena AI controller. This entity will contain all of your game logic for equipping items, inventory management, health, dealing damage, and so on. All of these parts come together to make up your AI character. So we have the foundation laid, but how are we going to control these parts? That's where the BP AI controller comes in. The essential part here is to ensure that your AI controller has the Athena AI component added to it. The Athena AI component performs 5 main functions. Initialization of the Athena AI system. It acts as a system entry point. It stores references to the various entities involved. It contains utility functions, and it handles cleanup. That's really all that there is to know about the Athena AI component. It primarily works autonomously in the background, handling things so you don't have to. Now you might notice that there is a further breakdown in this diagram after I just said not to worry about it. Within the Athena AI component lies the real meat of what we're here to talk about, the Athena AI preset and the Athena AI data manager. The Athena AI data manager is where all of the thinking takes place. Think about it this way. The Athena AI preset tells the data manager what to think about, and the Athena AI data manager does the thinking. Another way to think about this is that the data manager is all of the hard-coded logic, while the AI preset is where all of the user-defined data is stored. This would be the considerations, tasks, consideration curves, services, and gameplay tags. Now, let's talk about what each of those things are. We'll do a higher level overview in this video, and then in the next, I'll start my series on doing actual technical deep dives. Up first, considerations. At their core, considerations are quite literally just normalized float values. Considerations are your way of passing information from your AI character to the AI data manager. Inside the data preset, you'll be able to define tasks, and within each task, you'll add the relevant considerations to it. When task scoring occurs, the AI data manager will pull the normalized values from each of those considerations, multiply them all together, and then select the highest scored task. On the right-hand side of this slide, I have an example of what my function for handling consideration initialization looks like. Don't worry, it's not too complicated, I just have a whole lot of considerations. On the bottom left, there's an example of a float consideration. Note that we have to input values for the min, max, and initial values of these considerations. These are so the Athena AI data manager can properly normalize the values. And remember, normalization means that we're essentially just mapping those values to between 0 and 1. On the bottom right, we've got something a little bit different that I've touched on a few times, a Boolean consideration. Remember that in C++, a Boolean means true or false. We can also read that as 0 or 1. We can leverage this in Athena by representing true as 1 and false as 0, allowing us to still convert that value to a float. Now let's talk about tasks. Tasks are exactly what they sound like, some manner of achieving a goal. For instance, in my game, I have the task fire weapon. This is how the AI fires their weapon. I also have move to objective. Each of these tasks has their own set of considerations that again are weighted when task scoring occurs. Simply put, tasks are how anything actually gets done in the game. In the bottom left, I have an image of my task hold. I use this as my fallback task, where if scoring should come out to be 0, we go to that fallback task. All this does is simply tell the AI to do nothing for 1 second, and then try to score again. It's important to note that there are 2 vital parts, the event on task start, and most importantly, the finish task node. If the finish tasks node isn't included, the task will never end. This means that the data manager will never receive the flag to rescore all of the tasks, and will be stuck on this one until told otherwise. On the bottom right is an example of what the data preset looks like when creating a task. I'm not going to spend a lot of time on this, as we'll do a deep dive video on it soon, but I feel like this image highlights why considerations are so important. The AI needs a lot of data to make good decisions, and the more we give it, the better the behavior we get. Next, let's talk about consideration curves. I'm going to be brief on this topic as it has a lot of nuance to it. But for now, consideration curves are like the puppet master pulling the strings behind the scenes. They allow us to fine-tune the behavior of the AI behind the scenes by influencing the way that scoring occurs. I gave a brief demo of how these work in the Utility AI Overview video, but essentially you can just think of these as a simple algebraic function. We have some input x, and we evaluate where it lies on the curve, and that gives us our output y. Now let's talk about services. Services are a means of gathering extra data that we may not normally have access to in our character. You can sort of think of the environment query system as being similar to a service, but the idea behind them is that some condition is met, and then we start gathering data or performing some action. For instance, I have a service in my game called Distance to Objective. This service will only activate when the AI has an active objective. Once it does, it then updates the consideration Distance to Objective, which can then be scored based on its consideration curve. The further away the objective is, the higher the score is to head to the objective. Why is that? Well, the further away we are, we want to make sure we move in that direction. However, if we're already super close, let's say within 5 meters, and it's already being captured, then there's no point in heading to the objective. We've already arrived, and we're capturing it. One of the key aspects of utility AI development, in my opinion, is learning to make yourself think like the AI would. And finally, gameplay tags. I won't say too much on this topic, other than you should be using gameplay tags. They are extremely useful for many cases, but the key takeaway here is that all considerations and tasks will need to have gameplay tags associated with them. These tags follow the format of Athena AI.considerations.tagname and Athena AI.task.tagname, where obviously you replace your tag name with whatever you want the name of that consideration or task to be. Using these tags allows the data manager to easily identify what information is relevant to it. They also make life far easier when creating tasks in the data preset, as only the relevant Athena AI.considerations will show up there instead of all the gameplay tags. Alright, well that'll do it for this video. I think next time I'll do a deep dive on considerations and how to pick them, as well as some of the more deeper nuances about them. Cheers!